Hi, my name is Ryan Taylor and I go to the School of Science and Engineering in Dallas, Texas. And for my STEM project, I built a charger that recharges using solar and mechanical energy. In the future, I want to be an electrical engineer that specializes in energy and power systems because I want to help shift the world off of the dwindling supply of fossil fuels. If you look at the current energy model of consumption for the U.S. in 2019, you'll find that over 60% of our energy is reliant on fossil fuels, which are a non-renewable resource that contributes heavily to global warming. And that's why I decided to dedicate my career in order to developing new efficient forms of renewable resources and integrating them into our energy system in order to create a more sustainable future for the world. And that's what leads me to my project. It was a way in order for me to demonstrate my passion to engineering and display that I have the capabilities to research the materials and gather all the information necessary to complete this project, which I did entirely by myself. So, as we get into the project, I'll explain the general structure of it. There are two main mechanisms. There's the mechanism that charges the cellular device, and then there's a mechanism that charges the power supply for the first one, which are four nickel hydride batteries. So I'll start with the first. The structure of the first, we have our power supply, which, as I stated before, are four nickel hydride batteries. The nickel hydride batteries are then attached to a DC to DC boost converter, which amplifies the voltage to 12 volts, which so it can meet the voltage requirements for this USB converter, which I drafted off of a car charger. Because of the way a boost converter works is that it causes the voltage to fluctuate. And so in order to linearize that voltage so it can be used by our USB converter, I have a 12 volt voltage regulator attached to a 0.33 microfarad capacitor and a zero point 0.1 microfarad capacitor, which, as I said before, just helps linearize that fluctuating voltage in order to be used by our USB converter. So as we go into the second mechanism, we have our mechanical hand crank, which I got from a mechanical lantern, and I got a photovoltaic cell from the internet, which are attached to a Zener diode. So when the battery runs out of power, I can just attach it to this system here, which effectively allows for the flow of electricity into the batteries, while the Zener diode helps preventing back charge, which would damage these appliances. So that's it for the general structure of the charger itself. I'll just show it in motion. So I'll just plug it into. Yeah, so you can see that it's charging. So building this charger was a very valuable experience to me. It helped cement that. It helped me experience the challenges of being an engineer and going through the engineer design process. But it also helped me realize that how much of a passion that I had for engineering and how this is really the career that I wanted to be in. So, if you would allow it, then this scholarship would allow me to help invest into my success and help me to change the world for a better tomorrow. And that's all I can really ask for. So, thank you.